Welcome students, we come back again with a new video for class 12. Okay, we discussed already about the capacitance, that is its properties, what way capacitance, the value it may be apparent, that is Q, proportionality V and others lots of things, and the parallel plate capacitor also. So today we discuss the new topic. Which topic? This one is the capacitance of a parallel plate capacitor with medium in between the two plates. Okay, this medium, it may be conducting medium is placed or any other medium. So we just calculate the capacitance in this case. So first one, that is the capacitance of a parallel plate capacitor with a medium in between the two plates. Consider the first part, that is this one is positive plate. Okay, this is consider this plate is written in the P and another plate written with the Q. This plate P is positively charged and another plate Q, this one is negatively charged. Okay, and from the another side of it, it is connected to the ground. Connected to the ground, that means all the charge passes to the earth, and the separations between these two plates is D. Here it is mentioned, and the capacitance of this parallel plate capacitor C is C naught. Okay, so we last day we discussed about that. This one is the capacitance of the C naught in this case. So C0 equals to epsilon naught into A by D. This one is the value of the C naught. Now we want to calculate the value of E naught. So that is the electric field. If I consider this is equals to sigma by epsilon naught. This sigma is the charge per unit area. So surface charge density. So that is equals to Q by A into epsilon naught. So this is the first equations and this is the second equations. Okay. So C naught, this is the capacitance of the parallel plate capacitor, and E naught is the sigma by epsilon naught, that is equals to Q by epsilon naught. Now we want to find out the value of dV. So dV equals to minus E naught into dr. Okay. So what is dV equals to minus E naught into dr? Consider the charge is placed at these points. This point is located as a point A. Okay. This is negative, here positive charge is placed, and the charge body is moving away from the plate Q. Okay, so dr, this one dr, it is moving in that side. Okay, this is positively charged, this is negatively charged plate. So attracting force is created. So that means the electric field acting in that side, that is E. Okay, so electric field acting in that side and the charge body is moving in the opposite side. Dr is moving and in that side, electric field is acting in the opposite side. So what is the angle between them? That is the 180 degree. So we just write in this case that is E0 dot dr. So that means E0 dr cos 180 degree. What is the value of cos 180 degree? This one is minus 1. So we just write in this case that is dV equals to E0 dr. So we get the value of dV. So now we just integrate to get the total value of this. If I consider the V is the potential, okay, so V is the potential, so total potential, that is 0 to V into dV. Here the integrations occur from 0 to D because the distance between the two parallel plates, that is equals to D. So we just write in this case that is equals to integration of 0 to D E0 dr. Okay, so E0 taking common of this, so E0 integration of 0 to D into dr. Okay, what is the value of E0? That is equals to Q by A into epsilon naught. So we just write here that is Q by A into epsilon naught into dr, that means into D. Okay, that is equals to QD by A into epsilon naught. So this is value. Now we want to find out the capacitance. Okay, so this is the value of the VR, that is the value of the potential in this case. Okay, so value of the potential, that is equals to E0, this one, this multiply this, so it may be written in the form that is equals to E0 into D. Okay, so now we explain in this form, that is V equals to E0 into D. So this is the value of the potential when a medium is placed in between them. Consider the air medium present. So air medium, that is it is non-conducting. So now the question arises, this is the first case arises in this case, if the conducting medium is present, then what is the value in this case? Okay, if in between these two plates a conducting medium is placed, okay, so then we just want to find out the value of the capacitance, value of the potential, and also find out the value of the capacitance. So the next one, that is the capacitance of a parallel plate capacitor with conducting medium in between the two plates. Okay, just consider this P and Q. These are the parallel plate capacitor. We just placed a conducting medium, this one. Okay, the thickness of the capacitor medium, that is equals to T. This conducting medium or conducting plates just inserted between the two plates, that is the first plate P and second plate Q. We just inserted a parallel plate capacitor. This one is T. Okay. So now, due to the conducting medium, we just want to find out the capacitance of the conducting medium. In presence of the conducting medium, what is the capacitance changes in case? Okay. So just consider, if I take, that is the simply conducting wire. Okay, current just flowing or charge always present on the surface of the conducting. Okay, that means within the conductor there is no charge presence. So we just write in this case, that is within the conductor there is no charge present. So if I write, that is this is the conducting plates. Okay, so therefore what is the capacitance or what is the electric field within this? That is obviously zero, because conducting plates, the charges is present on the surface. So here total distance is D, conducting plates is D. Okay, small t. Now in D minus T, this is the distance where the air medium present. Just listen once again. This is the parallel plate capacitor P and Q. We just inserted a conducting plates. Okay, within the conducting plate there is no charge. So therefore the charge or capacitance is present. Due to capacitance we obtained from this space, that is the E0 and E0, that is where the air medium is present. Here it is and here it is. So what is the distance? This one total distance is D and conducting plates thickness is T. So now D minus T is the distance where the air medium is present, and for this particular medium we just get the value of the capacitance. So V equals to E0 into D minus T. Okay, so V equals to E into D, this one. This is the value of the potential. Here D can be changed to D minus T. Okay, so V equals to E0 D minus T, this one. Now UE equals to, it may be written as, that is sigma by epsilon naught. Okay, so Q by A into epsilon naught, this one. So this is the value of this, that is E equals to sigma by epsilon naught, just to be right. So sigma by epsilon naught, sigma equals to Q by A into epsilon naught. So putting this value here, so you consider this one is first equations and this one is second equations. Okay, so putting the value of E in the first equation, so we just write V equals to Q by A into epsilon naught into D minus T, this one. So now this is the value of the total potential within the medium, that is the except of the conducting plates. Okay, now we find out the capacitance. What is the capacitance in this case? So capacitance equals to Q by V. Okay, so capacitance equals to Q by V, this one. So what is Q? This one is the Q equals to, putting the value of Q, and V equals to Q by A into epsilon naught, that is Q by A into epsilon naught into D by T, this one. Now Q cancel out, that is A into epsilon naught by D minus T. This is represent the value of the capacitance. Okay, when the conducting plates is present between them. Now when consider D equals to T, the value of the T, thickness T, what is thickness T? That is the conducting plates. Now if I consider the conducting plates is placed between the P and Q, and the thickness of the T is equals to the B, that is the total thickness, that is in full medium is placed the conducting medium. So what is the diagram in this case? That is this one. Okay, this one is P, this one is Q. So that means total charge that is placed on the Q, it is passes to the, this is the conducting medium throughout. Okay, that is the distance DE throughout filled with the conducting medium. So total charge passes with Q and it is passes with the ground. Now, so when D equals to T, then C can be, these equations can be written in the form that is C equals to A into epsilon naught by D minus D. Okay, D minus D, that is equals to 0. So that is A into epsilon naught by 0, that is equals to infinite. So value of the capacitance is infinite when D equals to T. That is the thickness of the conducting sheet is equals to the total thickness between P and Q. Then we can write C equals to infinite. This is the value in this case. Okay. So that means when it is filled, that is P and Q plates is filled with the conducting medium, total charge given to the P and it is easily passes to the Q and then passes to the ground. So it can be taken as infinitely zero potential. Okay, because whole charge passes in the grounds. Just like that, if I consider if you take a bucket, okay, and the lower portions of the bucket is open. So if I pour certain quantity of water within this, any quantity of water within this, it is always passes to the ground. Okay, so that means same thing. The current passes to the P and it is moving towards Q. After that, it is moving towards the ground. And earth is considered as a zero potential. So what is the capacity in this case? Capacity is infinite. That is huge amount of capacitance is appear in this case. Okay, now we move to the next part. Okay, so the next part, that is the potential energy. Now we discuss the part. So potential, what is potential energy? Generally we know that for the mechanical energy can be divided into two parts, that is mechanical energy, that is potential energy and the kinetic energy. Here for the capacitor, potential energy is defined as, the potential energy of a capacitor is defined as the amount of work done to charge the capacitor. Consider you have a capacitor, okay, just consider the parallel plate capacitor. It is P plates, it is Q plates, okay, this one is grounded, so this is positively charged. Consider you just added some amount of charge. It may be dq amount of charge added together. Okay, so when this amount of charge added together, this dq amount of charge is coming from an infinite distance to a specific field. For this reason, work has to be done. Okay, so this amount of charge can move from infinite distance to a specific field within the capacitor. It can increase the capacitance. So this work done is called the total potential energy. Okay, what is the work done? That is force into displacement. That is dq amount of charge moving from infinite distance to a specific field. Okay, so the distance travel in this case and dq amount of charge is moving within the specific field. So this is considered as the amount of work done of a charge of a capacitor. So we just write here, so V equals to Q by C. So what is dW? That is total work done. That is V into dq. Understood? That is clear. That is dW, that is the total work done. Okay, so consider dq amount of charge. This charge is moving from infinite distance to a specific field. Okay, so total work done in this case, that is V into dq. Now what is the value of V? That is equals to Q by C. So Q by C into dq. So this is equals to work done for charge. That is which charge? That is small amount of charge. The charge is dq. Now we want to find out the total work done. So what is the total work done? That it will be represented as W. So W equals to integration of 0 to W dW, and here it is also integrate from 0 to Q. Consider the total charge moving from infinite to the specific field. That is equals to capital Q. So that is represented in the form that is Q by C into dQ. Okay, taking common Q by C, that is taking common only the 1 by C. So integration of 0 to capital Q, Q into dQ. So now it may be written in the forms. So that is 1 by C Q into dq. What is the integration? The integration formula that you know, integration of x to the power n into dx. That means x to the power n plus 1 by n plus 1. Same thing, q to the power 1. So it may be written as q square by 2. Okay, that is half, and it is integrate over the value that is 0 to q. Okay, so it is written in the form that is 1 by c into capital Q square by 2 minus 0. So what is the value? That is 1 by c, 1 by 2 q square by c. This is the total work done. So W equals to 1 by 2 q square by c. This is the total work done in this case. Now we know that what is Q? That is Q equals to CV. Okay, so V equals to Q by C, so Q equals to CV. So putting the value in this here. So that is W equals to half into C square into V square by C. So Cc cancel out, that is equals to half Cv square. This one, this is the total W. Okay. Now, so when we calculate the value of W, that is W equals to half into C into V square. So we just easily calculate in this case. Okay. Now this is the one forms to calculate the value of the work done or potential energy. Now if I know the value of C, that is the capacitance, obviously represented in farad, and V is the potential, by putting this value we can easily calculate the value of Q. Okay. Now again from these equations we write, that is C equals to, what is the value of C? C equals to Q by V. So we just write here, so that is W equals to half into Q by V into V square. So V square and V cancel out, that is half into Q into V. So this is the two expressions for the W. If I know the value of C and V, we just use this formula to calculate the potential energy. If I know the value of Q and V, we can use this formula and calculate the value of W in this case. So if I know any of this quantity, V is common quantity in both these cases, okay, and capacitance and Q, these are the two different cases. And so if I know the capacitance, we use the first formula. If I know the value of Q, okay, we use the second formula. So by using these two relations, we can easily calculate the value of the potential energy. Okay. So in this video, we describes the part, that is the parallel plate capacitor. In parallel plate capacitor, when a conducting medium is placed, what is the change in its capacitance occur, we also describes, and also describes in the part, that is the potential energy of capacitor, the total amount of work done when the charge is moving from infinite to the specific field. This value is to represent with the two forms, that is the W, that is the half Cv square and half Qv square. By using these relations, you can solve any type of problems related to the potential energy of a capacitor. Okay. So thank you watching, and everyone positively write these notes in your copy. Okay, and watching my video and subscribe my channel. Thank you everyone.